Welcome back!
Hey everybody, Stat and I are back. We're going to launch into stats! Yes, we're going to launch into the statistical part of simulation. As we reviewed in the last one, we did the single trial, mini trial, and now we're going to do the statistical work on the multiple trials. So, here's where things are going today. We're going to look at problem 2.2, problem 6.2, the real estate, the 4 problems looked at.
The correct statistics depends.
I'm talking, Stat.
I thought it was my turn.
Okay, fine. You explain this.
The correct statistics to do depends on what the actual question is. In the auction house problem, the question is how much money will they make? In the auto problem, the leasing, it's which option's cheaper, buying or leasing. And it goes on like that. So real estate, they want to know again how much money and what's the probability. There's 2 questions there. Kind of the same for the shipping docks.
Yes, so what will happen is as we get into these and dig into the statistics, different problems will have different statistics that need to be done. So we will jump into problem 2.2. What's the distribution of dollars? That's what they really want to know. And I've actually done part of it. And this is one of those situations, again, you probably want to have only one of these files open at a time, because there's a lot of recalculation going on and it's going to slow your computer down. As I said before, my computer probably has more memory than yours, so watch what happens. I'm going to hit the F9 for a recalculate, and you saw that delay. That wasn't a delay because we're on the internet. That was a delay because my computer took that long to do the recalculations here, 1,000 recalculations here, and another 1,000 recalculations here. Remember, we have 2 different models, the uniform sale price and the normal sale price. So I've actually done it for the uniform, so you can kind of see the complete solution. And the question is, what's the house net going to be? So the 5-number summary makes perfect sense. Mean, max, first and third quartile. Doesn't look good here that the first quartile is actually still negative. So in this particular set of 1,000 simulations, the lowest 25% were all still a loss, which means if we just ask the question, what's the probability of making money, where it's less than 75%. The interquartile range, if you want to know, in the full range, and we'll see why I care about the full range. Normally I don't. It's not a terribly useful statistic. Mean and standard deviation also make a lot of sense because some things pop up. If you look at the mean and look at the median, those averages are very, very different. And if you think back to your statistics, what does that mean? Well, the mean gets yanked whichever way the distribution is skewed. So if the mean is noticeably smaller than the median, the distribution is probably skewed to the low numbers, in this case losses. If the mean were noticeably higher than the median, that would mean that the distribution was probably skewed to large profits. So the numeric descriptive statistics are good, but you also probably want to have a graph, in this case a histogram. I'll show you how I made this one. I made this one using pivot tables. If you had me for statistics, that's how we made histograms. And there's a flaw here, there's a problem with this that I'll show you. We're going to do all of it step by step on the normal, but I wanted you to see the output. One thing quickly, let's do a recalc. There's the pause. Everything here changed, the data table didn't. Data tables need to be specifically refreshed. So if you change the data, you have to go to the data table and refresh the data. Now, this is the most recent data. Not that it changes it a lot, but this graph is not tied to these statistics and not tied to these outputs unless you actually refresh the data table. That's one of the drawbacks of the data table. Otherwise, it's not a bad method to do this. Early on, we talked about sample size. Why 1,000? Why 500? Why not 20,000? We've already seen the more we have, the slower it is on recalculation. The other issue I raised then is your sample size depends on what kind of margin of error you want. In reality, since we've only simulated 1,000 possible outcomes for this auction, and there are an infinite number of possible outcomes for the auction, this is not the population mean. It's a sample, it's an X bar. Well, then you think confidence intervals. So we'll go through the steps of how he did this, but if you want to be 95% confident, that Z of 1.96 should look vaguely familiar. It says we've got a 95% margin of error of $1,200 on this. So if someone were to say, well, what's the average income we're going to get in the auction house if we did this particular thing over and over and over? You say, well, our best estimate's $7,000. But there's a $1,200 margin of error on that, which means the mean could be anywhere between 6,000 and 8,300. That's a big difference. So if that's too large of a margin of error for you, then guess what? You need more than 1,000 trials, because the number of trials is what determines how big that margin of error is. We'll go through those formulas in a little more detail later, but just to remember that. So let's actually go and do this now for normal distribution. Well, since you've got this in yours, you can do this as easily as I can. I'm way too lazy to type those labels all over again. And you've probably heard me say more than once, spreadsheets are a lazy person's dream. I could be really lazy, and I should be normally. I should just copy the formulas. I'm not doing that this time because I want you to see how they're done. So, the min is the min. That's the Excel function for min, just like surprise, surprise. The Excel function for max is max. The function for median is median. And if you've encountered this before, there are actually a bunch of different quartile functions. And they all have some arguable flaws or strengths, so I just used the old plain old quartile. For our purposes, it is close enough for anything that we are going to do. So you ask, where's the data and what quartile do you want? So you get the first and third quartile. Now again, what's the 5-number summary? This tells us that 25% of the observations are between positive 7,000 and negative 39,000. 25% of the observations between positive 7,000 and positive 19,000. Another 25% between 19,000 and 21,000-ish. And then the largest 25% spread out between 21,000 and 28,000. This just breaks the data into equal observations and tells you how much space you need between them to get those observations. You can do a box and whisker plot if you have the tools to do that. The interquartile range tells us how many dollars, in this case, or what data we need. We need $14,000 to cover the middle 50%. So if you took out the smallest 25% and the largest 25%, all the data would just cover $14,000. Or all the data itself covers 53,000. So those tails, that highest and lowest 25%, are really quite spread out versus that middle chunk. And again, if you want to see a different set of 1,000, there's a delay because I've got a lot of stuff open and my computer's slow, but F9 will show you that. And it doesn't change them drastically. The mean is the frustrating Excel function because they use the word average instead of mean. The standard deviation. So we're assuming we have sample data. Oops, I typed that wrong. There. So we use the .s, the sample size. We already know that it's 1,000, but it's wisest to let the computer tell you that. So here we don't see quite the difference between the mean and the median. So the data appears that it's not quite as skewed, but still there's this noticeable difference. The median is still several $1,000s higher than the mean. So it does imply the data is still skewed to the low values. What if we want to do the margin of error thing? Well, confidence level, we'll stick with 95%. How do we find the critical z? If you remember the confidence interval formula, it's your point estimate plus or minus a margin of error. For means, the margin of error, we technically probably should use t-distributions, but I've got a distribution of, I've got 1,000 observations, so z's and t's converge, and the z is going to be close enough. So it's going to be the x bar plus or minus the appropriate z times the standard deviation divided by the square root of the sample size. I might actually put that formula in one of the PowerPoint slides later, but that should be vaguely familiar. But I got to find this. Well, it's the standard normal distribution, so it's norm.s, and it wants to know what's the probability. Well, I don't want to just put in 95%. This is not going to be the right value. This is 1.645. And for a 95% confidence interval, I'm sure you all have this memorized, it's 1.96. Well, why? Because what I did it one-tailed. I just put in 95% and it gives me the z that has 95% one way and 5% the other. For a confidence interval, I want the 95% in the center and the 2.5% on each tail. So I've got to take that 95% here and somehow turn it into either a 97.5% or a 2.5%. And I thought it was easiest to turn it into a 2.5%. Do it that way. In fact, some of you have probably seen an alpha over 2 notation in statistics books. Well, this is alpha. Alpha is 5% with a 95% confidence. Confidence is 1 minus alpha. So I've taken my alpha of 5% and divided it by 2. It's going to give me a negative number because it's down to the 2.5%. If I want to see the positive, all I have to do is go back in here and put the negative sign in front of it. So if I wanted 99% confidence, I get the 2.576. If I was happy with only 90% confidence, there's the 1.645, which you would have. 97.5% confidence, 97.5% confidence. And we'll just stick with 95% confidence. And we said the margin of error is your critical z times your s divided by the square root of your sample size. So in this case, if we can go and say if the sale price is normally distributed with a mean of 100,000 and a standard deviation of 16.5, which is a big if, it's a big assumption. If that's true, we can tell the auction house that if you do this process repeatedly, on average, you'll make about 13.5, and we're 95% confident that we're within 700 bucks on that average. That's not bad. So it's 13.5. Well, okay, 12.8 to 14.3. Yeah, it's not bad. Now, how do I get a visual picture? Well, we got two options. We got the pivot table option, and I'll go through that. Normally, when I've done pivot tables, gotta select my data there. There's my data. And notice I did just click a single cell in my data, and it selected column E. I don't care, it's not hurting anything. But I don't try to select my data. I let it select my data. It generally works better. Normally, I put my pivot tables off in their own worksheet. In this case, you could put it right in here, which is what I did on the mini trials. In this case, I'm going to go put it in my normal, completely new worksheet. I don't like the fact that it just named it sheet, so I'm going to change the name. And I'm going to name this one normal histogram so we can keep track of what's going on. So what do I want? I want the house net down into here, and I want to put it over here, and it sums it because it's a number, so I have to tell it to count it. So it shows me every single option that I had and how many times they happened, and none of them happened twice because I'm up to 6 or 7 or gazillion decimal places. I could try to fix the format here. Wouldn't hurt. And now I want to group. You need to know again kind of what's your minimum. So we're down around negative 32,000. In spite of the delay here, I'm going to hit a couple more F9s to see how much that bottom number changes. That's a big change, negative 42,000. negative 38,000, negative almost 40,000, negative 47,000. I need to know that because this is a little different than just doing a normal grouping. Normal grouping, I'd group based on that. But when I go over here, right-click, notice where I went, I right-clicked on a single cell, and I say group, I want to start down at the lowest negative number that I can kind of expect to get. So I'm going all the way down to negative 50,000. On the high end, that's 29. I'll go 30,000 for now. And I forgot to check the high end on that, by the way. I'm already over 30,000, so I might need to go higher. So let me do a couple of these F9s again. I wasn't paying attention to the max. I've only been over 30,000 once, so I'm going to go up to, I'm probably going to go by 500 instead of, or 5,000 instead of 10,000s. So I'm going to go up to 35,000 and change this to 5,000s. There's no hard and fast rule on what those numbers should be. You want to generally include your lowest and your highest. The pivot table will tell you, by the way, if you mess that up. I'll show you real quick. So let's say that I wasn't paying attention and I did negative 25,000 instead of negative 50,000. It will tell me how many are below that. That technically breaks the quote-unquote histogram rules, but it's not a disaster because it will tell me. It won't just make them disappear. Make sure I got, okay. One thing you have to be aware of, you always got to keep an eye out for missing data. If there's a lot of gaps, this data is not skewed enough that I would expect a lot of gaps, but you should kind of scan down here. And 0, 5, 10, 15, 20, 25. The other way is 0, 5, 10, 15, 20, 25, 30, 35. I don't see any gaps. You can kind of see here already that it's skewed, but you should finish off the histogram. Oops. The house net. Get rid of all the gaps. I'm sick of the blue, so I'm going to go with, since it's money, green, outline them in black. So there's your distribution of the house net. So yeah, there's a reasonable chance of losing money, perhaps losing a lot of money, but the probabilities are pretty small. The vast majority bunches up here. I mentioned before, though, you see me hit F9 over here a few times. I need to refresh this if I want that to be reflected here. So let me go refresh all. Changes it a little bit. Didn't change it a lot. Got a little bit lower on the low end. Nothing much changed on the high end. Did make my graph a little bit bigger. I think for this one, I'm going to go ahead and stop with this style of histogram. On the one of the future problems, I'm going to show you a different way to do histograms. It's just histograms that cause enough trouble. I don't want to throw two different methods at you in one problem. So take a look at this problem. Look at the stuff that was pre-done. Look at the stuff that we did later. And this won't be here. You have to add these yourself. Well, this sheet will be here, but this will not be there. You have to add that yourself. See if you can do this yourself. And look at the stuff that I had done for you. Take a look at that one.